electric force. Remember Newton's law of gravitation? It looked like this, all right, where capital G was his universal gravitational constant, M1 and M2 were the masses of the two objects, and R is the distance between their centers of mass. Remember that this was a field force, all right, so it could act at a distance, and we treated our objects as point masses at their center of mass. Electric force has a very similar format. Here, Fe, all right, go back to our force subscript, it's a capital E, is equal to K, all right, which we'll get to in a second, Q1 times Q2. Here, Q is the variable for charge, all right, over R squared. K is equal to 9 times 10 to the 9th newtons times meters squared divided by Coulomb squared to make the units work out. This K is also known as Coulomb's constant, and it is on the back of your equation sheet. So if you look at this, the magnitude of your electric force between 2 point charges is just going to be the absolute value of what you get when you plug in all the values. Because electric force is also a field force, your point charges do not have to be touching. All right, so here R is the distance between the centers of your point masses. So if it's not actually a point mass, it will usually be something like a sphere of charge, and then just like we use the center of mass, here you're going to treat objects as a point charge at the center of their charge distribution. This equation is also known as Coulomb's law, so sometimes you'll hear the electric force referred to as the Coulomb force. Talking about using it, if one charge is negative and one charge is positive, then you'll have one negative sign in your equation, so the force comes out negative. That makes it an attractive force. This goes with what you've always learned in opposites attract. If both charges are positive or both are negative, then you'll either have two negatives, which multiplied together become positive, or there's no negative signs in the whole thing, in which case your force comes out positive. This is a repulsive force. Again, this goes with like charges repel. And in terms of the direction, the force is always directed along the line that contains both charges. Okay, just like when we talked about Newton's gravitational law, it was always directed straight towards the center of mass of the other object. Now it's straight towards the center of charge of the other object. So this one, you might have to do some straightforward calculations, or you could get asked some mathematical reasoning questions, like what happens if I double the charge or double the distance, or other things than doubling, but you've seen those before too. So as a reminder, if you double either charge, the force doubles. If you double both charges, you have it doubled twice or quadrupled. If you double the distance, since the force is proportional to 1 over r squared, the force becomes 1/4 the original value. And here's a picture to maybe make that a little bit clearer. You saw similar pictures when we talked about gravitational forces.